Hello, welcome back to Algebra. We're now going to focus our attention on taking our basic shape of a parabola and shifting it left and right. That means we're only going to shift the parabola along the x-axis. In the previous lesson, we talked about shifting the parabola in the y-axis, so if you haven't watched that, please stop and go do that now. Now we'll be talking about shifting parabolas in the x direction, and then in the next lesson, we'll shift it on both directions at the same time. So we're kind of inching our way there. So to get started, I want you to reacquaint yourself with what I've left this on the board the last several lessons because it's the basic shape of a parabola. So we have the basic parabola shape. Vertex is at the origin. This is a table of values for this parabola. Y is equal to x squared. Now you all know by now that the general idea or the general form of a parabola for how it opens and closes as far as being steep or shallow is a times x squared. The number in front here, a, governs how steeply or how shallow the parabola opens up. We talked about that before. So this table of values is the basic shape where we have a equals 1. So it's basically y is equal to 1x squared, and here is the table of values. Basic parabola, vertex, which is the minimum value right at the origin. And then, in the last lesson we talked about shifting horizontally. So I'm going to relabel this. I'm going to say this is a summary of vertical, which is what we did in the last lesson, vertical shift. And I'm going to mark up this board a little bit because I want to inch you there one step at a time. And by the way, at the end of the lesson, we'll have another computer demo, so please stick around for that because the computer can really help solidify things after I've done the lecturing. This was a summary of a vertical shift. So here's your basic parabola, no shift when it's just ax squared. When you add a 1 to the side, another way of thinking about it is pulling that 1 over next to the y, and that is shifting up 1 unit. Similarly, shifting 3 units would look like y minus 1 equals ax squared. And so shifting down is when you have an opposite sign. So I told you in the last lesson to, in your brain, when you have the shift written next to the variable on the left-hand side of the equal sign when we're shifting up and down, that if it was a minus sign, you're shifting up in the positive direction. And if it was a plus sign, you're shifting down, going kind of in the negative direction. So it's kind of exactly the opposite of what you would expect. And we went through great lengths to explain why that is the case in the last lesson. So if you haven't watched that, please do it now. But this is the results of that. Now, what I want to do, I want to make two little changes to this. And I want to do, their changes don't matter, but they will help you understand today's topic. Here I have the y minus 1 in this example written on the left. I'm just going to put a parentheses around it. You would agree that parentheses don't change anything. It doesn't make it a different expression. I'm just kind of grouping it together, and you'll understand why I'm doing that in just a second. I'm going to put parentheses around that because I'm going to say this kind of goes together. And I'm going to put parentheses around that, which kind of says that this goes together. And you already know this because we've talked about the shifting so much, but when we shift up 1 unit, for instance, let me use this color. When we shift up 1 unit, which is this equation, as an example, then in general what I'm talking about is, I don't have that much space to write it, but basically if this is your xy plane, then if instead of the parabola coming down like this, it's shifted up 1 unit, which is what I'm trying to represent here. This is 1 unit shifted in the up direction, so a minus sign means we shift up 1 unit. And as an example in the other direction, I'll draw a quick little axis down here. I should have drawn it kind of a little more favorably, sorry about that, but minus 2 means we're going to have 2 units down, and this parabola is going to be, that's a very bad drawing, I'm sorry about that, but it's supposed to be kind of like centered right there. The vertex is 2 units down. So downward shift, upward shift, and now I've drawn some parentheses to group them here. So what I'm going to do is now I'm just going to write on the board what it looks like when you shift a parabola left or right. And then after I write it down, you're going to scratch your head and say, that makes no sense at all. But then you're going to have to listen to me talk for a minute so you'll understand why. I could just tell you to memorize it, but that's no fun. Plus, you're just a monkey and you're just not doing any thinking. I don't want you to be a monkey and do anything. I want you to understand. So I'm going to write down how it looks to shift left and right, which is a little bit weird looking, and then you'll fully understand it when you listen to me babble on for a few minutes about it. All right, so I'm going to do it on this board. So we're going to talk about the horizontal shift. And the reason I present the horizontal shift after the vertical shift is it's a little bit harder to understand, but I will make it clear. Horizontal shift of a parabola. So what do I want to do? A horizontal shift looks like this. A horizontal shift looks like this. The basic equation is y is equal to x squared. So if you shift horizontally, it's going to look like this. Parentheses, x minus 1 squared. right? This is a shift right. Let me erase this actually. We're going to shift the equation. Let's do it like this. We're going to shift the equation right 1 unit. 1 unit. And I'm going to do a quick little sketch. It's not going to be a graph in all of its glory right here. I want to get as much on the board as I can, so I kind of have to squish things in a little bit sometimes. So if the basic parabola goes and touches down in the center like that, so when we shift 1 unit to the right, this is 1 unit to the right, the parabola is no longer centered in the origin, it goes like this. That is what we say when we say 1 unit shifted to the right. Now, before we go any farther, because I'm going to give a lot more examples and I'm going to talk to you a lot about why it's happening. Before we go any farther, I want you to go back to what you already understand. A vertical shift up, which is this, whenever you have the +1 on the right-hand side, can be written like this, with the -1 on the left-hand side. A minus sign shifts it kind of in the positive y direction. A minus sign in y here shifts it in the positive y direction. I'm telling you, without any proof yet, that a minus sign here shifts it in the positive x direction. So really what you need to know is that when you write the shifts next to the variables, you just go in the opposite direction of the sign. If it's a minus sign, it's shifted to the positive direction. So if it's a minus in y, it shifted positive y. If it's a minus in x, it shifted positive x. Okay, and that's why I put these parentheses around, and that's why we kind of do one before the other. So this is a single unit shift to the right. What do you think would happen if we wanted to shift 3 units? 3 units to the right, or I'm sorry, 3 units to the left would be x. Instead of minus, it would be plus. Okay, notice it's still squared. That makes your allows you to have a parabola shape. This is a shift left 3 units. 3 units. Now, what do you think that looks like? A shift left of 3 units looks like this. Here's -1, -2, -3. I have to extend my graph a little bit. So this is -3, and that means the graph no longer goes and it's centered touching the origin. It goes down and touches the -3. So the vertex is right here at -3. That's what we mean when we say it shifted left 3 units along the x direction. So of course this is x and this is y. So we've kind of established that a negative sign shifts to the right, a positive sign shifts to the left, but just for giggles, we'll do one more example where we say, what happens if we have the equation x minus 4 quantity squared? This means we shift, because it's a minus sign, it goes opposite, so to the right, 4 units. And what does that look like? I don't really think I need to draw it, but I will anyway. So we have 1, 2, 3, 4 units to the right. The parabola is now centered there. And of course my shape isn't exactly right. You got to realize it's going to have that perfect parabola shape. When I'm drawing it freehand, I'm not going to be able to do that. All right, so that is the bottom line. That's what you're going to see in books. You're going to see an equation that says, hey, if you want to shift a parabola to the right, then you put parentheses around the x squared term. Remember the basic equation for all of these is just x squared. What you're doing is you're replacing the variable with the parentheses and you're putting a shift inside, and that whole thing is squared, right? And so it's like x squared, but you have now a shift in there, and that whole thing has to be squared. And I'm telling you kind of without proof that when it's a minus sign, it shifts that many units that way. When it's a plus sign, it's that many units shifted that way. But what we want to do now is discuss why that's the case. And that takes a few minutes to explain, but it's not crazy hard, but you need to kind of open your mind, because it's the first time I learned it, it was very hard for me to understand. I'm going to try to short circuit all of the difficulty and try to cut down to the bottom line here. I think the easiest way to do it, first of all, is do a table of values. So let's take, let me think, do I want to do the table of values here? Yeah, I want to go to the next board. I'm going to take one of these examples. I'm going to take this first example. X minus 1 quantity squared. This is the one we're going to work with. We're going to do a quick table of values on that, and we're going to examine it in detail. So if you have x and y equals x minus 1 quantity squared, and we're just going to do a table of values. This is exactly what we did when we did the previous shifting. And we're going to go -3, -2, -1, 0, 1, 2, and 3. And I need you to kind of bear with me, because we do need to plug these values into here. And I want you to see what the outputs really look like. So let's start with 0. That's actually easier. If you put 0 in here, then what you're going to get is 0 minus 1 quantity squared. That's what you would have if you put it in there. And of course you get negative 1 quantity squared. You're just going to get a 1 out of that. Now if you put a 1 in here, 1 minus 1 is going to give you, we'll do it like this, 1 minus 1 squared is going to be 0 squared, which is going to be 0. So when you put a 1 in, you actually get a 0 out. When you put a 2 in, what do you get? You get 2 minus 1 quantity squared, which is 1 squared, which is 1. Now I want you to stop for just a second. I haven't filled the rest of the table out, but I want you to see that you can already see some symmetry forming in here. Notice that there's always symmetry. In that first example, the symmetry was about this point. All of the numbers on both sides of 0 were symmetric. That's why the graph is symmetric about this 0 point right here, right? But already, before we even finish any other part of the table, we already see that we have a center point, kind of, with some symmetry on both sides, but it's not located in the middle, it's shifted so that the symmetric point is at x is equal to 1. What did I tell you? I said that when it's minus 1, it's going to be shifted to the right. That means that the center point of the parabola should be shifted over 1 unit, and we're already seeing that the center point of the parabola is actually shifted over 1 unit before we even finish the table. But let's go ahead and finish the table because it's helpful. 3 plugged into here will be 3 minus 1 quantity squared, which is 2 squared, which is 4. All right, so we have these values. Let's go to the negative territory, right? So we're putting negative 1 in here. Negative 1 minus 1 quantity squared, that's negative 2 quantity squared, which is 4. Let's pause for a second. See how we have a center point? We have symmetry here, and we have a 4 and a 4. We have symmetry building here. Now let's put a 2 in here. Negative 2, I'm sorry. Minus 1 quantity squared. This will be negative 3 quantity squared, which is going to give you 9. And the last one we'll do is this one, negative 3 minus 1 quantity squared is negative 4 quantity squared. I can barely fit it in here, it'll be 16. Now I didn't continue my chart this direction. I could do that. In fact, it might be a good idea to do that. Let's go up 1 more unit to 4, and let's put it in here. 4 minus 1. I didn't do this on my paper, but let's do it here. 3 squared is 9. Now the 9 you see matches the 9 up here. And just for absolute completeness, we'll go to 5. 5 minus 1 quantity squared is 4 squared is 16. So the 16 matches the 16, the 9 matches the 9, the 4 matches the 4, the 1 matches the 1. 0 is now in the center. This parabola is centered here. This is the center. However, the center of this parabola is no longer at x is equal to 0. The center of this parabola is now shifted 1 unit over to when x is equal to 1, right? And that's the bottom line. So this is a graph of a parabola that looks something like this. If you were to graph it, I'm not going to do it rigorously, but if you do this guy, x minus 1 quantity squared, the basic parabola would go in the center like this, but this is shifted 1 unit over like this. And it's just too sharp here. It's more flattened out in the real shape of a parabola, but I'm doing things freehand. So the bottom line is, when you have a minus sign here, it's shifted over. So that's kind of like the first veneer layer of explaining to you why shifts work like this. Of course, a table of values helps you understand, but I want to probe just a little bit deeper, talk a little bit more so you understand. Why is it really shifted to the right? Let's write this equation down in large letters, right? Y equals x minus 1 quantity squared. Why am I writing it in big letters? Because I want you to focus on this thing right here. This is a parabola. What it means is that whatever is inside, and I want you to listen carefully here because these following words are the most important in the whole lesson, right? Whatever is inside of this thing, inside of the parentheses, the whole enchilada inside of here, whatever is in here is what is squared. So if I stick a 3 as the whole thing inside here and squared, I'm going to get that 9. If I stick a 2, the whole thing, the entire thing evaluates to being a 2 in the inside, then I get the 4 out. If I stick in whatever I put in here on the inside of those parentheses, if I end up with a 5 in there after I've done everything, if I get a 5 inside the parentheses, like the whole thing, then I square it, I get the 25. The shape of the parabola basically comes about because whatever I have in here is squared. And so then I build my table of values. But notice that whenever I have something like x minus 1 squared, then what ends up happening is I have to have the easiest way to think about it is to do the following. Sorry to switch gears on you, but let me go back to this. The basic parabola shape is f of x is equal to x squared. When I put a 0 into this, I square it and I get a 0 out. That is why the center of the parabola is right here. So let's focus on this point, this one right here. Let's focus on this point right here, 0, 0. I put a 0 in, I get a 0 out. If I put a 0 in and end up squaring it, then I get a 0 out, okay? But what happens in this equation is the only way that I can get a 0 in here to square it is I have to have an x value 1 unit bigger than I do for the base equation so that I can have a 0 in there. Why? Because I have to have a 1 here for x to make 1 minus 1 to give me a 0 here to square it. So in other words, the bottom of this parabola is always going to happen when whatever I'm sticking in here is 0, and then I square it, and then I get a 0. That's the bottom of the parabola. But the only way to get a 0 in here is to have to feed it an x value 1 unit bigger than the basic equation. The base equation being y equals x squared. Stick a 0 in, get a 0 out. But here, if I stick a 0 in, I just have -1 squared, and then I have a 1. That's not the bottom of the parabola. The only way to shift that 0 point to the right is to feed an x value in here 1 unit bigger than I'm originally feeding for the base equation. That's why it shifted to the right. You see, that happens for every single point, right? So if I put a 1 in here, which is this point right here, a 1 minus 1, 0, square it, that's the very bottom of the parabola. And it happens for every other point here. So that's why the center of the parabola is now at this point when x is equal to 1. If, in an alternate universe, I had the equation x minus 4 quantity squared, this equation, this parabola, is a basic parabola shape shifted 4 units to the right. 4 units. 1, 2, 3, 4. Why? Because the only way that I can put a 0 in here to square it, to get 0 as the bottom of the parabola, is to put an x value in. That's an x value along the x-axis, 4 units bigger than usual. So that I have 4 minus 4, that gives me 0, and I square it. You see? And so that's how you need to think about horizontal shifts. You need to think of it, this x minus business here means I need to be feeding values into the function 4 units bigger to get to the same bottom point of that parabola that I do in the basic function. That's about as clear as I can make it. I want you to roll that around your brain a little bit and make sure you kind of understand. And the same thing happens in the other direction. See, we didn't do a table of values. But let's do it for I've already told you that shifting to the left, I said, hey, if you have, I can just look at this one here. If you have the equation x minus 4 squared, that's a shift, I'm sorry, x plus 3 squared, that's a shift to the left 3 units. Why does this thing shift it to the left 3 units? Because the only way that I can get a 0 in here, which is going to be squared to give me a 0 for y, which will be the bottom of this parabola, the only way that can happen is if I stick a value of x in here 3 units less than usual. -3 plus 3 is 0, which is squared. That's why it shifted to the left. And that process happens for every point on the parabola. So when you think of the parabola as a curve traced out by all of these infinite points, right, x comma y, they all end up being carbon copied and moved over because of that shift there, the x minus thing here. Because as I feed numbers in here to have the same base, it's easier to think in terms of the origin, 0, 0 point. You need to have it, in this case, 3 units smaller than 0 in order to get -3 plus 3 giving you 0, which will be the bottom of the parabola. And of course, the same thing happens for all the other points. So that's a lot of talking. Most books are just going to tell you, if it looks like this, it shifted left. If it looks like this, shifted right. But I want to give you a little bit more than that. So now I think we're ready to write down my little summary, which is something I did before. Where did I run out of space here? Let me put it over here, I guess. So I'm going to do a little summary of horizontal shift. I'm going to do a summary here. Now, in all of these examples I chose, I said, well, it's like x minus 1 quantity squared. But you all know that there's another little part of parabolas. You can have a number in front of the x, right? It's ax squared. So in general, when the shape is a little more general than what I have here, for instance, the equation y is equal to a parentheses x minus 1 quantity squared, you shift the equation ax squared right 1 unit. See, in these boards, I just eliminated a because I'm trying to make it easy for you. Now I'm opening things up and I'm saying these parabolas can have another value in front of the x, which determines how narrow or wide the parabola is. But whatever this number is, you're just shifting the whole thing to the right 1 unit, right? Let's pick another one. If you have ax minus 6 quantity squared, you're going to shift the equation, the base equation, ax squared, right 1 unit, or right 6 units. Why 6 units? Because, of course, there's a 6 right there. And then lastly, we're going to go the other direction. We're going to say y is equal to ax plus 7 quantity squared. We're going to shift the curve ax squared left. How many units? 7 units. Right? Same sort of thing. I need a negative 7 in here just to get a 0 to square it. That means that the center of the parabola is going to be shifted left 7 units. So in general, the most general thing that you might see in a book is you might see something like this. Let me write it under here. I have a little more room here. In general, right? In general, you're going to see something like this. Y is equal to ax minus h quantity squared. Right? And then what you see usually under that is if a is greater than 0, not a, sorry, if h is greater than 0, h is greater than 0, you shift to the right h units. Shift right h units. And exactly the same thing. If h is less than 0, shift left h units. Because if h is less than 0, h is negative. So if h is negative, it's x minus a negative, which means it's x plus something. So when you see an x plus something here, you shift it to the left. When you see an x minus something, you shift it to the right. This is what you'll see in a book for shifting horizontally, right? But usually they won't explain it or even tell you why it works or whatever. They'll just tell you to memorize it. But now you can kind of see the symmetry of what's going on. When you're shifting in the y direction, you put your shift kind of in parentheses near the y variable. If it's a minus sign, you're shifting the parabola up. If it's a positive sign, you're shifting that parabola down. For a horizontal shift, you write that shift next to the x variable. Again, you have parentheses. It's got to be squared because it's a parabola. X has got to be squared. And then if this is bigger than 0, you're shifting to the right. If it's less than 0, you're shifting to the left. So if it's like a -1, you shift to the right. If it's like a -4, again, you're shifting to the right. If it's a plus, you're shifting to the left. And I tried to explain why that works by just thinking about the table of values. So what I want to do now is follow me onto the computer demo where I can play around with it even more and show you how the shifting really works. Okay, welcome back. Here we have shifting quadratic equations horizontally. So right now I want you to focus on this side. I have the parabola x squared, y is equal to x squared graph. This is the same graph for the basic parabola that we always do. And then what's above here, ignore the 1 for right now. It's x minus, in this case, 0. There's no shift at all. That's why the parabola is sitting right here at the origin. Now, if we make it x minus 1, what happens? Okay, first ignore this for a second, and let's take a look at the table of what's going on here. What's happening is, let me go back for a second and you can see a little clearer. Right here, this value is 20. Let's go to the 1 value, or the 0 value. Let's go here. It's 0, 0, but when I move it over, you can see that that 0 point here I've highlighted in red has now shifted down in the table. So now it's 1, 0. And if I go over, it's 2, 0. And if I go over again, 4, 0, and so on, as I change that guy, you can see the parabola dancing left and right, and you can see this red 0 shifting around, and that's the 0 point of the parabola. So when you have something like x plus 2 squared, it's a left-hand shift, and now the 0 point of the parabola, is here. Right? Why? Because I need to stick a -2 in here for x in order to give me a 0, in order to give me a minimum of the parabola way down over here. And so as you go deeper negative, same thing. I need a -3 in here to give me a 0, to give me a square, to give me a minimum in the parabola. And so as I'm shifting the parabola around, if you look at this red 0 here, you'll see that minimum point of that parabola dancing around, and that is why the shifting really happens. You can pick any other point on here you want to. Let's go to x minus 1 squared and take a look at the value right above it. When you put a 0 in, you get -1 squared, giving you +1. And all of these are basically just plugging in the table of values directly into this equation, as we said. So this whole shifting business happens for every one of these points. That's why the whole entire shape of the curve is what is transferred, because the shifting doesn't happen for any one point. It happens for any value of x we stick in here. All right. Now, one more thing I want to talk to you about. Notice over here, I have something like this. So I have x minus 1 quantity squared. Where did I get this from? Remember, you already know how to take x minus 1 quantity squared and how to do FOIL on it. That's x minus 1 times x minus 1. So FOIL, if you do the first outside, inside, last multiplication and collect terms, this is what you're going to get. So these two things, these two equations are exactly the same thing. Y is equal to x squared minus 2x plus 1 is exactly the same thing as y is equal to x minus 1 quantity squared, because if I do the FOIL on this, this is what I get as an output here. And you can see that that's happening. I've done the equation two ways because I want you to understand that basically when you see a parabola like this, if it has a square term like this right here, then you know it's a parabola. But looking at it like this doesn't really give you any idea which way it shifted. I mean, x squared minus 4x plus 4, it doesn't tell you at all that it shifted 2 units to the right. You basically can't tell by looking at this where this thing is shifted. It's very hard to tell. But you can tell very easily by looking at this version over here. Right? So this version over here, when we're talking about shifting parabolas, is usually what we focus on. But just keep in mind, you can do FOIL, and this is a totally equivalent way of writing the parabola. It's just you can't see very easily how the thing is shifted. So we can go over and look at another one, like x plus 3, or x plus, let's do x plus 3 quantity squared. So you can see very easily that this is shifted 3 units to the left. But when you blow it out with the multiplication, this is what you get. And you can't tell which way this thing is shifted by looking at it. But just keep in mind, there's always two ways to write parabolas. You can write them all blown out and they're full-blown multiplication. And then you can also compactify, factor it, and then this can tell you more readily which way the thing is shifted. The last thing I want to leave you with is also very important. This whole shifting business, for this equation, I have a 1 out here because, remember, the general form is ax squared. Now let's change it to make it a 2, or let's change it to make it a 3. See, it makes it more and more narrow as I increase this guy. So let's land on 4, quantity x minus 0 squared, which means it's basically 4x squared. This is the table of values. But whenever I go to the right, that shape is what is shifted to the right. So the shape of the curve is really governed by the 4 that's out in front. The shifting is governed completely by what is inside of the parentheses here. And if you take this x plus 1 quantity squared and do FOIL on it and then multiply by the 4 on the outside, this is the full-blown equation that you get. Again, you can't tell which way the thing is shifted by looking at that. You kind of have to use these other forms, and that's why we're learning them, or one of the reasons why we're learning them. But no matter what shape you pick, the shifting still happens exactly as you would expect. And notice that 0 point going up and down. In fact, even if I turn it upside down and make it like negative 2x squared, the minus 2 means that shape is shifted to the right, and the plus 3 or plus 4 means it's shifted to the left. So all you have to do to worry about the shifting is figure out what's inside the parentheses. That tells you how it's shifted. The coefficient out in front tells you if it opens up or opens down and how narrow the thing is, because you can see that it gets more narrow as we change that coefficient. So now follow me onto the board. We're going to complete and conclude this lesson. Hello, welcome back. I hope you've enjoyed the computer demo. I like putting them together because it really can help solidify some difficult kind of concepts ahead of time. It's very, very powerful, I think, for you to see how things move around by just dragging some sliders and you can see a bunch of equations at once. There was one thing that I showed in the video demo, or the computer demo, that I want to point out here. Notice I want to show you one more thing that I did talk about in the computer demo, and that is that if we're talking about these parabolas being shifted left and right, this is the best form to use because it's very easy to see how many units the thing is shifted. But keep in mind that this is still a binomial squared. This is a binomial squared, and you can expand and multiply these guys out as follows. For instance, this would be x minus 4 times x minus 4. And you know how to do this multiplication. Just multiply it out, and you get x squared minus, this is 4x. Outside terms will give you minus 4x. And then negative 4 times negative 4 is positive 16. And so what you'll get is x squared minus 8x plus 16. So the equation y equals x squared minus 8x plus 16, if you make a table of values and plot it, it is exactly the same thing as this. Why? Because this is just a factored form of this, that's all, right? But it is very hard to look at this thing, this x squared minus 8x plus 16. It's basically impossible to look at it and off the top of your head know where that parabola is shifted. But by having it in this form, it's very easy, because when you factor it and get it into this exactly this easy to understand form, we already know that anytime it's x minus something quantity squared, we just shift the basic shape to the right, right? So sometimes you'll see parabolas written like this, and sometimes you'll see parabolas written like this. And I remembered the first time I learned this stuff, I was like, why do we have different ways of writing stuff? Well, the truth is, they both represent the same thing, but writing it in this form, which is what we're focusing on in these lessons, is much, much easier for figuring out where the thing is moved to. That's why we have different ways of writing things. So make sure you understand this. We have now covered the concept of shifting a parabola horizontally. And in the previous lesson, we've covered the concept of shifting a parabola vertically. Now in the next lesson, we're going to combine those two and shift a parabola anywhere in the xy plane using a vertical shift combined with a horizontal shift.